Hi guys, good afternoon. I am out all week with COVID. So I do just want to go over the last gas law that we did not get to in sixth period. Um, you guys are not learning anything new this week. You are just practicing your use of gas laws and figure out which gas law to use and when. So you are going to be working on practice questions, finishing out the packet, and then I will be posting some exit slips later this week. And there will be a simulation that you guys will do tomorrow. You guys will get that packet from the sub. We are obviously not going to do the test on Friday because I will not be there, but I want to do the test on Tuesday when I get back. I won't see you guys on Monday because Monday is MISA testing and only periods 1, 2, 3, and 4. I'll see if you guys are ready for the test on Tuesday. We might push it back to Wednesday, but we'll see. Okay, so let's talk about the last gas law, which is the ideal gas law. All right. Okay, so the ideal gas law is right here on screen. It is going to be PV equals nRT. So pressure times volume equals N times R times T, which is temperature. So we know PV and T already. We know that P stands for pressure, and the pressure is going to be measured in atmospheres, kPAs, or millimeters per mercury. And then our volume is going to be in liters. For this particular formula, the volume is always going to be in liters, so we cannot use milliliters. If you have a problem that gives you milliliters, you have to convert that to liters. So how do we go from liters to milliliters? Or actually, let me back up. Our question is more, how do we go from milliliters to liters? So 1,000 milliliters equals 1 liter. So whatever value of milliliters you guys get, the decimal point will be back here. We will move it 1, 2, 3 to the left, and that'll give you how many liters you have. So for example, if I tell you that you have 25 milliliters, we're going to move that decimal point back here, 3 to the left, 1, 2, back up. That did not go correctly. 25, decimal points back here. We're going to move it to the left, 1, 2, 3, and then we'll fill in any empty loops with zeros. So 25 milliliters gives us 0.025 liters. Sorry, my handwriting is not the best. Okay, and then we have a new guy. N is going to be the number of moles. So remember our moles from before. R is going to be something called the ideal gas constant, which means the number is always going to be the same. And then T is going to be temperature, and the temperature has to be in Kelvin. So we cannot use Celsius for this. So going off of that, remember, how do we go from Celsius to Kelvin? This conversion is easy. All we do is we add 273 degrees. So remember, let's say that we have something like 4 degrees Celsius. 4 degrees Celsius is going to be the same as 277 degrees Kelvin. Okay, so let's talk about R for a second. We have a little table at the bottom of the slide. Depending on what your pressure is, and again, your pressure can be kPa, millimeters of mercury, or atmospheres. Depending on what your pressure is, you're going to use a certain number for your gas constant. So if you are using a pressure that is in kPa and the volume is always in liters, the moles are always in moles, and then your temperature is always in Kelvin, the value of your gas constant is going to be 8.314. If you are given a pressure that's in atmospheres, your gas constant is going to be 0.08206. If you are given a pressure that is in millimeters mercury, then your gas constant R is going to be 62.36. So that is the value you guys should use for R. You don't have to memorize it. We'll give this to you guys. And this is on the back page of your packet on page 22 by the staple. Okay, so let's try to use this gas law. So first question says, what is a gas's temperature? So we're trying to figure out the gas's temperature when it has a volume of 25 liters. So remember, we have to be in liters, and this is in liters, so that's good. We've got 203 moles, and we've got a pressure of 143 atmospheres. So again, because we're using atmospheres, the value of R is going to be 0.08206. Okay, so we can plug all of those in. We don't know temperature. We have a volume of 25, so that'll go over here. We have 203 moles, that'll go over here. We have an atmosphere pressure of 145, that'll go over here. And then we have R, which will go right here. And then we have to figure out T. So we can plug all of those guys in. So this would look like our pressure multiplied by our volume, 143.5 times 25 equals our moles, 203 times R, which again is just going to be this number down here, times T. So we fill in our R, and we know our R based off of our fact that we're using atmospheres. And then we can solve for T. So what we should do here is we should solve for the left side. Move this guy. See if I can move this guy out of the way. Solve for the left side. 143.5 times 25 is going to give us 3,587.5. And then you should multiply together your moles and your R constant. 203 times 0.08206. And that's going to be 16.66. And then we'll be left with T. So if you divide both sides by 16.66, then you can isolate the T. So if you would divide by 16.66, the 16.66 over here will cross out. T will be by itself. And then we also divide the other side by 16.66. And that will give us 215.34 K is our temperature. Okay, so this one is pretty easy. And then our second question says, what is the volume of 1 mole of an ideal gas? What is the volume of 1 mole of an ideal gas at STP? And STP is standard temperature and pressure, which is 273 K and 1 atmosphere. And we're looking for the volume when we have 1 mole. So because we're using atmospheres, again, when you use atmospheres, you're going to use this number as the R value. And then we can plug everything else in. So we have 1 atmosphere for the pressure. Let me see. This is my pressure over here. This is my temperature right here. These are my moles over here. This will be my R value down here. And the thing that I'm trying to figure out is my volume. So we can plug all of that into the ideal gas equation. So we'll end up having 1 atmosphere times volume, which we don't know, equals 1 mole times the R constant, which is 0.08206 times 273, which is our temperature. We can calculate everything that we have on the right side of this equation because we don't have any variables. And then we can divide by 1 over here to isolate the V. And the answer should be 22.4 liters, which was a constant that we were using when we were doing our mole conversions. 1 mole of any gas is always 22.4 liters when we're at standard temperature and pressure. So we should recognize that number. Okay, so that's ideal gas laws. What we want to do now is we want to work on pages 16, 18, and 22, working on applying Charles's Law, Boyle's Law, and ideal gas laws um, as our practice for today. So by the end of today or tomorrow, we should have the entire packet filled in. So make sure you work on that. And I will talk to you guys tomorrow about the next things that I want you to work on. So, again, we'll be doing a packet about gas laws in class. You guys will get from the sub, and then I will be posting exit slips so you guys can practice for your test next week. I hope you guys have a good day and that you do not get COVID. Bye, guys.